Hello ladies and gentlemen, welcome to my video. This is today's question. At the first look, it doesn't look difficult. Maybe substitution such as u equals to 2023 cosine x or sine x can be solved. But truth is no, we can't solve it using simple substitution. In this video, I would like to share solution using Feynman integral tricks and Euler formulas. First is to rewrite q become a function qa. The equation almost the same to q, but replace the 2023 with parameter a. For this question, a must be a real number. Once we solve function qa, we can get q by set a equals to 2023. Let's look at Euler formulas. E power ix equals to cosine x plus I sine x, which means e power ix equals to e power a and then multiply cosine x plus I sine x. It can be rewrite as e power a cosine x multiply e power ia sine x. For the e power ia sine x, we further expand using Euler formula. So it becomes cosine a sine x plus I sine a sine x. Now we compare this equation with the integrand of qa. They are almost the same other than integrand of qa without the imaginary parts, which means qa can be rewrite as the real part of the integral 0 to 2 pi e power a e power ix dx. Apply differentiate of qa over dA. The left hand side is q prime a, while for the right hand side it is almost the same as before other than there is a partial differentiate over dA for the integrand. The differentiate of integrand over dA is equals to the differentiate of the exponential part and then multiply the original terms. Remember, when we differentiate the exponential, it is over dA. That gives us e power ix multiply e power a e power ix. So we have a new updated q prime a, which is almost like a previous one, but with the new integrand that we just found. This newly found q prime a is integratable using substitution or antiderivative methods. The differential over dx for e power a e power ix is equals to the differentiates of the exponential parts multiply the original terms. Be careful, the differential of exponential part is over dx. The result of differentiation is equals to ia e power ix multiply e power a e power ix. So the antiderivative of this equation is actually equals to the indefinite integral of our function q prime a. So now we have a simple q prime a, which is equals to the real part of 1 over ia multiply e power a e power ix for x equal to 0 and x equals to 2 pi. Refer to the Euler's formulas again. E power I 2 pi equals to cosine 2 pi plus I sine 2 pi, which is equals to 1. E power I 0 equals to cosine 0 plus I sine 0, which is equals to 1 as well. So therefore, q prime a is equals to 0. Q prime a is not what we want. We would like to get qa back, which is equals to integral q prime a dA equals to 0a plus a constant c. Of course, just a constant c. Now, how do we find value of c? Recall that there is another version of function qa that we defined at the beginning of this video. Let's copy it and put it here. For this version of qa, when a equals to 0, qa equals to integral 0 to 2 pi e power 0 multiply cosine power 0 dx, which is equals to 2 pi. The constant c equals to 2 pi, or qa equals to constant c equals to 2 pi for a equals to any real number, including 2023 mentioned in these questions. Conclusion of this video, the answer is equals to 2 pi. Thank you for watching my video until the end. Please continue support my channel, subscribe, give a like and share my video with others. See you tomorrow for another video. Bye bye.